Let's do all the rules. So first rule is the product rule. That is, if the base is same, the exponents or the powers get added. So base is same, for example, here, and the powers get added. Let's take an example, t raised to power 3 times t raised to power 4. And now if we make them negative as well, we take that example, negative 3 times t raised to power negative 4. So the rule remains same, that the base is same, powers get added. This becomes, then normal addition rules apply. 3 plus 4 is 7. Negative 3 plus 4, which gives us negative 3 plus 4, 1, which is nothing but t. And then t raised to power negative 3 plus the negative 4. Now over here, plus minus becomes a minus, and t raised to power negative 7 is what we got. So this is how we are going to apply the product rule. Any questions in the product rule? Now similar is the quotient rule. In the quotient rule, nothing changes, just instead of multiplication, there would be division. If there is division, the powers get subtracted, that's all. So instead of plus, it becomes a minus. Instead of plus, it becomes a minus. Instead of plus, this becomes a minus. So 3 minus 4 is nothing but minus 1. Minus 3 minus 4 becomes a minus 7. Then minus 3 and minus minus becomes a plus. So in this case, it is negative 3 plus 4, which is power 1. So this is how we are going to apply the quotient rule. So in the product rule, the powers get added. In the quotient rule, powers get subtracted. Any questions in this? No. Okay. Then let's go to the power of power rule. Now let's say x and it has some power 3 and it has another power, let's say 2. So in this scenario, the powers get multiplied. 3 times 2, x raised to power 6. Now how is this happening? X raised to power 3 means x is getting multiplied thrice and its power is twice. That means x square times x square times x square, which is nothing base same powers add 2 plus 2 plus 2, x raised to power 6. And similarly, even if we are taking the outside power first, that is x cube power 2, that means x cube times x cube, which is again base same power get added. So x raised to power 6. So power raised to power is nothing but multiplication of the powers. So there comes a third rule. After this, here is power of a product rule. So there is some product we are having. For example, we are given 10 and 10's power is 3. We can say 10 is nothing but 2 times 5 power 3. So that means it's 2's power 3 and 5's power 3. So that is what the rule is telling. A b raised to power m is there. So it's nothing but a raised to power m and b raised to power m. Any question regarding the power of a product rule? Okay. Now, power of a quotient rule. Let us say we are having 10 over 3 raised to power 5. So this becomes 10 raised to power 5 and 3 raised to power 5. That means we can separate the powers on both on top and the bottom. And now the zero exponent rule. Zero exponent rule says anything raised to power 0 we do, it will become 1. For example, if we have 10 raised to power 10 over, let's say 10 we have already taken multiple times, let's say 7. So 7 raised to power 0 is actually 1. Now how is this happening? See, if there was 7 raised to power 3 over 7 raised to power 3. We know the 7 raised to power 3 and 7 raised to power 3, we can apply the quotient rule. That is, if they are in division, their powers get subtracted. 7 raised to power 0, right? And we know if we cancel out the 7 raised to power 3 and 7 raised to power 3, which is 7 raised to power 3, 7 raised to power 3, which is 343, 343. And if they get cancelled with each other, we just get a 1. So that means this thing and this thing should be true. So 7 raised to power 0 is 1. And similar is for any other number if we want to try. Be it a negative number, let's say negative 1000 raised to power 0 is nothing but 1. So anything raised to power 0 is 1, and that is our 0 exponent rule. Any questions still here? All right. Then there is a negative exponent rule. Now, what does the negative exponent rule says? That if the power is negative, let's say 2 raised to power minus 3. So what we can do is we can write it as this way. Or if we are having 2 raised to power 3, we can write it as 2 raised to power minus 3. Now, how is this happening? See, if there was 2 raised to power 3 and if there was 2 raised to power 6, we know that let us do the exponent way. Base is same and they are in division. 2 raised to power minus 3. And we know if we solve it this way, 2 is multiplied thrice here, 2 is multiplied 6 times here. And here we can cancel the 3 2's with the 3 2's. We are remaining with 3 2's, which is 1 over 2 raised to power 3. So that means this thing is actually equivalent to this thing. And this is our negative exponent rule. Then there is fractional exponent rule. Now, what does it mean by the fractional exponent rule? Now, if we have 2 raised to power 5 over 2, or let's say it's a 5 over 3, that is a cube root. So what it means is that we can write it as 2 raised to power 2's cube root raised to power 5. Now, how is this happening? Because we know the power rule says power to the power. Here. Sorry for the mistake here. Times 1/3. And this is what? 2 raised to power 5 power 1/3. Or we can write it as 2 raised to power 1/3 power 5. Both ways are good. And this is nothing but the cube root of 5, cube root of 2. And the power is 5. So that's why we can represent a raised to power m over n as a nth root power m. It is the same representation here. All right. Any questions still here? No? All right.